In this video I'm demonstrating some of the new motion capture tools we've been developing that enable management of live motion capture streams. So in this, on the right hand side here I have Natural Point's Arena software, which can be used to simulate a motion capture session. This is just playing back recorded data from a previous motion capture session, and it's streaming it over a network port. On the left hand side here I've got a Fabric application which is connected to that live arena stream, and it's showing a character retargeting that motion on the fly onto its own skeleton. So I just want to show you a bit more about this motion. I can scrub through time and go to any point in this motion, and as I move this slider, our character on the left hand side is updating in real time. And this character on the left hand side is has different proportions to the character on the right hand side, and the retargeting system in Fabric is actually doing a dynamic pose adjustment to make sure that the character actually fits the pose. So I just want to come over here and pull it out a little bit, and I want to show show the skeleton. So this is the skeleton of my character. Ignore these floating points here. They're face and toe bones that weren't used in the enveloping. If I turn off the skeleton, show a bit of debugging, what I want to show now is some aspects of the retargeting which basically enable this system to work, to enable that runtime fitting of motion capture data. So how it works is this is kind of a traditional rig which has IK controls where the hand can be controlled using a position value and the feet can be controlled using position values, or FK where the arms and legs can also be controlled just using angle values. So what this system does is dynamically blends the arms and legs between IK and FK to best use this incoming data. So in this first pose, the two legs are in IK, so the feet are sitting on the ground, the feet are constrained to the position on the ground where the original motion capture data specifies, but the arms are ignoring the original motion capture data and instead sort of going to the most relaxed pose possible. Now, as we come through the motion, there's a point here where the right hand drops down and touches the ground, and during that action our character blends the right hand from IK to FK, and at the same time we also introduce a retargeting operator also modifies the posture of his torso so that his right hand can actually match that pose. If he stands up again, I'll go to the point where he stands up. As he stands up, note at this point his right hand is still touching the ground, but as he moves it up, it sort of releases that constraint and his arm goes back to a natural pose. So the idea is that as the hands and feet, or any other part of the body for that matter, the pelvis or the chest, comes into contact with a constraint target, that constraint dynamically turns itself on and off. At the moment we can only constrain the pelvis, chest, hands and feet, but eventually we can really constrain anything. We could do dynamic head constraints and knee constraints. So just playing back through this motion again, it is doing a bit of fitting, and I can actually go to a point in the motion and turn off the fitting just to show what happens without this retargeting. So I'm going to scroll down here. This UI on the left hand side is showing the user interfaces for all of the solvers applied. So we can see there's humanoid leg solver right here, humanoid arm solver, and then what follows them is the full body retargeting solver, and it's an iterative solver. So I can come back down here and set the iterations to 0. And what that means is that we're still doing the dynamic blending of IK and FK, but it's not doing actually any fitting of the data. So his legs are too long here for the data, so he's kind of squatting down a bit, which doesn't look very good. And if we scroll through time, whenever he does some more complex actions, the arms may not reach the target, or they might be too close. So if I go to that point where he goes onto his arms, in this case the legs look fine because they've blended to FK, but the arms tend to look bad because the head is pushing into the ground and then the elbows are pushing in. So this is a good point to highlight what the retargeting solver does. If I set it to 1 iterations, it's kind of done a little bit of a fix up. 2, 3. So now I've got 3 iterations in the solver and it's starting to look pretty good. I can go straight up to 5. 5 is already looking pretty good. So I had it at 10 earlier, which does a sort of pretty accurate constraint, which now we can see that the arm is resting on the ground accurately. It's pushed the chest up enough that the shoulder is, the elbow is now not pushing into the ground. And so we can look at the character's pose a little bit. It would have pushed the chest to the side a little bit. Go back to that first one and then go back to 10. So it has changed the pose of the character a little bit, but due to the fact that these constraints blend themselves on and off fairly smoothly, we actually don't notice that change in motion too much. So this full body retargeting solver enables us to use animation data from one character on another. Effectively, that's what it is. It's a system of transferring skeletal data from a source skeleton to a target skeleton and doing a fitting in that process. I can just quickly show you the debugger here. Oops, that's docking is not all that useful at the moment. Zoom in here, and these are the solvers applied to my character. And these are what's called inversion solvers. So inverters are used to transfer the motion from one character to another, and the solver here is used in the fitting of that motion directly on the character. I'm going to look at the dependency graph, which is the underlying operator graph that's actually executing, and here we can see the code for the full body solver. So I'm going to just click on that, and I can see the code for the full body solver here. And as you can see, it's not a lot of code. It's basically a point spring model, which is iteratively relaxed to try and maintain those constraints, and the lengths of the springs are modified according to the source animation data. So the system is designed that it can be extended according to specific character requirements. Some characters might have more differently configured legs or arms, and it's expected that we'd have to modify this solver for some complex or different characters. The off-the-shelf solver that we've got right now will work in most cases, and we'll probably have to put more work into the dynamic constraint management. This demo is just really showing working on a flat ground, but in more complex environments we could add those extra features as required. Or actually our customers can. It is all of the source code for this solver is given away as part of the creation platform, so you can take a look at it and play with it and modify it according to your own requirements. So that's it. Thanks for listening.